So in this problem, we're being asked to sketch these angles in the unit circle, and we have different pieces of information about each one. For this first one, we want an angle with a positive cosine value and a negative sine value. And so if we keep in mind that the cosine value always tells us the base of the triangle or the x-coordinate along the circumference of the circle, and that the sine value always tells us the y-coordinate, what this tells us is we are looking for points along the outside of the unit circle that have an x-coordinate that's positive and a y-coordinate that's negative. Well, for the x-coordinate to be positive, we know it has to be on this half of our unit circle. And for the negative, for the sine to be negative, it means it has to be below the x-axis. So we're looking for any of our angles that are here in this fourth quadrant. So you could draw in any of those angles at all, and that would work just fine. So I'm going to go ahead and just draw in this angle here, right? And that angle, if we go from 0 degrees, because this coordinate here on the outside would have a positive x-coordinate and a negative y-coordinate, we know that the cosine will be positive and the sine will be negative. So in this one, we're looking for all angles that have a sine of 1/2. And using what we were looking at before about how the sine tells us the y-coordinate, we are looking for points along the circumference of the unit circle that are 1/2 above the x-axis, because we want a positive 0.5. And if you remember from our special triangles that it's a 30, 60, 90 triangle, it has a hypotenuse of 1, that the shorter leg is 1/2. Well, we know that to get a sine with a y-coordinate of 1/2 has to be 30 degrees to the right, or another one that has that same reference angle of 30 degrees over here in that second quadrant. So here are the two angles. There's 30 degrees here, and then the second one would be 180 minus 30 degrees, or 150 degrees. So we have 30 degrees and 150 degrees. And you can always check those on your calculator just by doing sine of 30 and sine of 150. Of course, make sure your calculator is in degrees and not in radians. Of course, we should also be able to name and use those angles in radians as well. And since our unit circle is labeled in radians, that actually would have been the better choice. So if we convert those, this would be pi over 12 radians or 11 pi over 12 radians. So you could check those in your calculators as well. To go ahead and draw an angle that measures 4 pi over 3 radians, one of the things we can notice is that 180 degrees is pi radians. And so a third of that, right, if this is pi, this is pi over 3 radians, or a third of all of that. And that's going to help us to be able to do 4 pi over 3, right? So if here is pi over 3, or 1/3 pi, then this would be 2/3 pi, 3/3 pi, and 4/3 pi over here. So we can go ahead and sketch that in about here. Four pi over 3 radians, right? There's our starting angle, there's our ending angle. The other thing we could do is, if it's easier for us, we could convert it to degrees, right? So 4 pi over 3 radians. To get from radians to degrees, you're going to multiply by 180, and then we're going to divide by pi. And so once we simplify that fraction, the pi and the pi just reduce to 1. We have 180 in the numerator and 3 in the denominator. If we reduce that fraction, divide by 3, we would get a 1 in the denominator. Divide by 3, we get a 60 in the numerator. 4 times 60, this equals 240 degrees. And so if you go ahead and look at our angle, if this is 180, we need to do another 60 degrees, 240 degrees. This last one, we're being asked to draw an angle with a negative cosine and a positive tangent. So just remembering that cosine, we can see the cosine of any angle by examining the x-coordinate of the point that intersects the circumference of our unit circle. So really, we need to make sure we have a negative x-coordinate. So that means it's going to be somewhere on the left-hand side of our unit circle. So that really eliminates all of our angles over here. So then on the left-hand side, the other thing we know that we need is we need a positive tangent. And tangent, we know, is opposite over adjacent. And we know that's the same as sine of our angle, sine of theta or sine of x over cosine of our angle, right? Well, the only way that we're going to get a positive here is if sine and cosine are either both positive or both negative. So if I examine my unit circle here, if I'm looking at this quadrant here, the second quadrant on the top left, my x coordinates are negative, but my y coordinates are positive. So if my x coordinates are negative and my y coordinates are positive, we're going to end up with a positive, let me change to a pen, a positive over a negative, and that's going to give us a negative tangent. That's not what we want. So we can eliminate the second quadrant as well. So the only angles that are going to give us both a negative cosine and a positive tangent have to be here in this fourth quadrant. So you can draw any angle in that fourth quadrant, and that angle there will give us, we'll start here at 0, right? This will give us a negative cosine because its x-coordinate is negative, it's to the left, and a positive tangent because both the x and y coordinates will be negative.